Hi everyone, this is Math 176, Spring 2020. This is your second lecture video. This lecture video is going to talk briefly on section 6.2, the trigonometry of right triangles. For those of you that have taken Algebra 2 in high school or taken trigonometry or pre-calculus in high school, you have seen this material before. For those of you that have not, that's okay. We're going to talk about this in depth today. Well, we're going to talk about this in this lecture video, and we will talk about this in depth in tomorrow's Zoom meeting. So, in this section, we're dealing with the trigonometry of right triangles. I have written down two mnemonics involving this section, SOHCAHTOA and also SHOSHIKAO. On my right here, let me just circle this really quickly right now with the Galaxy pen. On my right here, I have a right triangle. I have these letters in purple, O, A, and H. And I have an angle theta, and I have a right angle for this right triangle. For that angle theta, the O, the A, and the H are defined over here on my left. The side that is opposite theta is called the opposite. I denoted this by an O. That is not a zero. The side that is adjacent to theta is called the adjacent. I denoted this by a lowercase a. The hypotenuse is denoted by h, and that's the hypotenuse of the triangle, the longest side of a right triangle. For a trigonometric function, you have the following definitions for sine, cosine, tangent, and their reciprocal functions. What I am about to say here is extremely important, and I want you to remember this from here on out in this class and in your future math classes. The way my trigonometric functions work is as follows. I plug in an angle, like this guy here. I plug in an angle theta. My output is a ratio of two sides of a right triangle. So in the case of sine, when I plug in the angle theta, sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. Tangent is equal to the opposite over the adjacent. On the right here, on this right-hand side, I have also the reciprocal functions. Remember that cosecant is defined to be the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. To help you remember these definitions here for sine, cosine, and tangent and their reciprocal functions, you have the following mnemonics, which I wrote here on the very top, which I'm going to box here very briefly with that rainbow. There was once so this is a story that was told to me in one of my classes, okay? Actually, you know what? I'll save that story for tomorrow's Zoom session. Here are the two mnemonics that you have for remembering the definitions of sine, cosine, and tangent, and also cosecant, secant, and cotangent. SOHCAHTOA and SHOSHIKAO. The capital letters represent the functions. The purple letters represent the sides of that triangle. So sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And so on and so forth. We had talked briefly about these definitions here back in chapter 5 when I made the connection back to how sine, cosine, and tangent are defined in terms of a reference number t. I also wrote down these definitions here for cosecant, secant, and cotangent. They are defined to be the reciprocals of sine theta, cosine theta, and tangent theta, respectively. Before I work on a quick problem and end this video, I want to remind you of this. You will hear me say this a lot throughout this class, for this trigonometry portion of the class. The way my trig functions work, I plug in an angle, like this guy here, I'll call it theta. My output is a ratio means fraction, is a ratio of two sides of a right triangle. Which two sides those are is dependent upon the trig function. So here's a quick example problem. Let's suppose you've got a right triangle here. Let me draw the 90. Suppose you've got a right triangle here. The sides are listed, and you were asked to find the 6 trigonometric functions of theta. Okay, so how do I do this? Sine of theta is the opposite over the hypotenuse. Your opposite is 4, your hypotenuse is 5. So sine of theta is 4/5. Cosine of theta is defined to be the adjacent over the hypotenuse. So that will be 3/5. Tangent of theta is the opposite over the adjacent. So that will be 4/3. Cosecant, secant, and cotangent are the reciprocal functions of sine theta, cosine theta, and tangent of theta. So let me just take reciprocals of what I have here on the left-hand side. And just like that, I have slain this problem. Okay, everyone. That about wraps it up. I will see you in tomorrow's Zoom session.